been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen, so in the future, if we want to keep doing something, we need to know why something stopped in the past that we wanted to keep it going. Money is a good thing.
Then in 2002, Blue Marble 2.0. NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the Moderate Resolution Imaging Spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
But we're also really pushing the boundaries in terms of where we're going forward with exploration. I think humans are naturally driven to do this, and this is really the beginning, I think, of human beings leaving low Earth orbit. I certainly plan on being around to see that.
The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the farthest that we can go. We only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to, and we're building these building block components in order to allow us to do that eventually.
A group of social criminals, these people in the space program, nassholes I call them.
You're the one who said you walked on the moon when you didn't. Calling the kettle black if I ever thought of it. Saying I misrepresented myself.
Away from me.
You're a coward and a liar and a thief.
You want me to knock you in the head?
Well, I want you to swear to God on the Bible that you walked on the moon.
Okay.
If you walked on the moon, we're given the opportunity to swear to God that you walked on the moon.
I'm going to give you the opportunity to get the hell knocked out of you if you don't leave me alone.
So why don't you just put the end to the record in the argument, then put your hand on the Bible, swear to God you walked on the moon.
Mr. Several, knowing you, that's probably a fake Bible.
Well, you're talking to the wrong guy. Why don't you talk to the administrator in NASA? We're passengers. We're guys going on a flight. Of course. I don't hit people, but you're going to be on the deck unless you get
I'm heading out. I appreciate it.
and get the hell out of the clubhouse.
Well, I
Take your stuff and get the fuck out. Why don't you quote me and say it's bullshit? When the shadows in the wrong place, I don't give a damn about all that shit.
shit of lunar orbit being falsified.
Being falsified?
Correct. We've got an unedited tape from a source at the Johnson Space Center.
Totally nonsense.
Mr. Seibel, you do not deserve answers.
If you show this publicly, you're open for a lawsuit. Okay?
Naturally, we have to pass through this danger zone twice. Once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
Both the thermosphere and exosphere have temperatures ranging from 0 to 2000 degrees Celsius. So I decided to examine the melting points of the primary metals that we use to build the lunar module. First off, we have the aluminium alloy, which has a melting point of 463 degrees Celsius. Next we have stainless steel, which has a melting point of 1510 degrees Celsius. Then we also have nickel steel alloy, which melts at 1453 degrees Celsius, and of course the heat resistant glass for the windows, which has a melting point of 760 degrees Celsius. So this would mean that the lunar module, along with its occupants, would have disintegrated well before it even passed through the thermosphere, let alone surviving the Van Allen radiation belts in the exosphere. To protect the astronauts from the Van Allen radiation belts, the lunar module would have required 6 feet of lead shielding. But here's what they really had for protection.
Obviously, the only shielding they had was the literally paper-thin outer hull of aluminum, and their suits consisting of glass fiber, some aluminum fibers, and silicon rubber.
It's very interesting concerning radiation that the astronauts were protected by a thin film of aluminum when here on Earth they put a lead shield on us when they take a dental x-ray.
In conclusion, when NASA themselves admit to never having left low Earth orbit, and the fact that we don't even have the materials that could withstand the extreme temperatures and cosmic rays in space, how on earth can anyone believe that we ever went to the moon?
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.